All right. Hello, everyone, and welcome. I hope everybody is doing well. We are going to pick up where we left off on the last stream, and we're going to kind of actually change direction a little bit from what I was thinking of doing last stream. And we're actually going to tackle something else that I've been kind of thinking we might want to tackle anyways. But before we get into that, I do just want to take a quick second to thank our supporters of the channel, beginning with our elite partner, Javier Lazaron, followed by our partners, Gobullies Inc. and Matt Oscard. Those are the highest tiers of subscription over on Patreon and YouTube memberships, followed by the list of other supporters you see here on the screen. They're a combination of the other tiers of support over on YouTube memberships, Patreon, and Twitch subscriptions. So thank you all very much for your support. It is greatly appreciated and helps me offset the cost of running the channel by, offsetting costs of things like software licenses, hosting fees, things of that nature. So thank you all very much for that support. I greatly appreciate it. Of course, I appreciate each and every one of you viewers, whether you're joining me here live, either on the Twitch side or the YouTube side. We do simulcast to both. Or if you're just catching the VOD after the fact, I very much appreciate you guys being here as well. Without you guys, this channel and this project would not exist. So thank you guys very much for being here. Maget's, good to see you. LSR, good to see you as well. Yeah, I know. I had the debugger up for a minute. But yeah, we batted that away, right? Okay, so let's get into what we want to kind of tackle tonight. So I've got a couple of new lines of code here with a left off saying, why not just have this? So in the last stream, we were kind of running into some issues with our hierarchy node. Essentially, it was causing a seg fault. Now, I don't know exactly where the problem was. I didn't have time to debug it. But I got thinking, the whole reason that we set up this hierarchy graph in the first place was really because we used to have the requirement that some of our nodes weren't necessarily going to have transforms, and we wanted the ability to have a sense of hierarchy without always having to have a transform, right? And we decided for the simplicity of things that we're just going to dispense with that requirement, right? So our new scene system, or our new scene rather, for our game-specific scene, now has a transform on every single entity, right? And so I got thinking, this hierarchy graph is actually doing a lot of extra work and a lot of extra things that we don't necessarily need it to do anymore. And I don't really think we need this. I think we could actually simplify this down a lot and get rid of a lot of the extra data that we're holding and a lot of the extra lookups that we're doing by just rolling this straight into the scene. So I think the hierarchy graph is going to be another thing that we're going to dispense with. And instead, we are going to store the hierarchy as part of the entity information. How are we going to do that, you might ask? So I believe it's just going to be as simple as doing this, right? So we have an array of Illumina entities called children, right? And if that array exists and has members in it, then we have child entities that belong to this one. If not, then we don't have that, right? And I'm not sure that we're going to need any sort of parent lookup, but a parent lookup would essentially just be another Illumina entity that would sit right below it. Now, all that this is going to require, because our Illumina entity actually tells us a lot of different information, right? Our Illumina entity already tells us what the type of child entity it is, and it also tells us what index within that array it is, right? So we don't even have to do any lookups there. It's already stored in that handle for us. So all we're doing is keeping a list of handles that we've created anyways, essentially. And so why not use that to just make lookups pretty simple, I think, right? So it's not like we're keeping pointers to other types of entities and stuff like that. We still actually get all the benefits of using our lookups, right? We just have to sort of manage, adding child entities and removing them and so forth. But I don't really think that's going to be all that complicated. So that is what is on the roster tonight, is to sort of rethink the way that we're handling entity hierarchy, and we're going to do this instead. I think it makes a lot more sense. Excuse me. Seeing you over there on the YouTube side, how's it going? Good to see you. All right, so I guess I'll just change this to an array of, actually we'll say a D array, right? That'll make this the easiest to manage, of child entity handles, right? And then that's all we essentially have to add to each one, right? I don't know, like we could also do Illumina entity parent. We could do that. I just don't know that we're going to need it, right? So I'm going to hold off on adding that for right now, and if we need it, we'll add it. Okay, so I'm going to close out this hierarchy graph. Oops. How did that close my entire Vim? I closed one pane. Unless I typed capital Q, maybe that actually closes out the entire thing. All right, whatever. So let's go to, oh, this is hierarchy graph. I don't want that. Illumina scene. There we go. So we're going to, essentially, along with this, we're going to be fixing the transform issues that we have. Just as a reminder of that, what we're seeing there is basically our transforms just aren't working, right? So when we run the application, you know, we can move around, but we actually see that stuff's not working correctly, right? There's supposed to be a cube kind of moving around with us, and these things aren't supposed to necessarily be located right there either, so... this should fix all of that stuff. All right. So what we are going to do first is, I guess we'll set up, actually we'll remove all of this stuff with hierarchy graph. So we're going to get rid of this and the array of hierarchy nodes. We no longer need that, right? That's a bunch of information that we're having to store to use that hierarchy graph, and now we don't need that anymore. And you can see this actually caused a lot of errors, which is fine. But this is also going to allow us to not have to like store these extra things, right? So I'm just going to kind of go through here and just remove all the references to entities. Now, I should say the hierarchy node. So getting something like the entity child count now is just a essentially let's see, so we get the hierarchy node index, so we actually don't need the hierarchy node index at all anymore. So what we really need is we need the use, actually, yeah, we need the Illumina entity type, right? So we want to get the type. And we want to say Illumina entity unpack type. We'll pass entity. And then we want to do U16 index, or type index, I guess we could say. And we'll do Illumina entity unpack type index, right? Entity. So we have those two things so we can actually perform our lookup. So I guess we probably should maybe have sort of a generic lookup for this, but I think for now I'm just going to kind of put it here and then maybe make like a internal utility function for this. So we'll switch on type. Right. So entity type none. What we're really after is we're after that that D array list, right? So we want Illumina entity array children, right? And we're going to set this to 0. And so for type none, that means just a typeless entity. So that means children is going to be equal to scene entities, children, right? And that's all there is for that one. So break, and then static mesh is essentially just going to be a lot like the other ones, or all the other types, right? So static meshes. And this time we're actually going to, oh, you know what? This is wrong, actually. This should be entities sub type index dot children, right? So static meshes sub type index dot children, right? Oh, it's gonna be base. That's my bad. I knew I was forgetting something that didn't look right. Okay, so all the rest of the types are essentially going to look like this. So what I'm going to do is I'm actually just going to paste this in here a bunch of times, and then I'm going to go back and fix all the various types, right? So entity type count and invalid, obviously we don't count those. But what we're going to do to cover those types is we're just going to say default up here, right? So height map terrain, we don't have this one yet. So if we get that, we're obviously going to have to throw some sort of error. So we're going to say height map terrain entity not supported, not yet supported, right? Because we'll get to that eventually. And in this case, we're actually just going to come down here, or actually, I guess we could do here. We'll return 0, right? And we'll just comment out that, right? So this is going to be water planes. This is going to be audio emitters. This is going to be volumes, hit shapes, point lights, spawn points, right? So we'll have the children array down here, and then all we have to do is say if not children, first off, return 0, right? Length of 0. Otherwise, we're going to return, and we'll say U16 will cast. We'll say darray length children. And then we don't need the rest of that, right? Now, this is obviously a lot. We don't want to have to be doing this all over the place. So I think it's prudent to perhaps maybe have like a internal sort of static function that maybe just returns this, right? So, you know, we could say like get entity, or get children for entities, right? Or get children for entity, rather. So we would do a Illumina entity, and we could do, I guess let's make that static, and we'll do get, actually, you know what? Why don't we just make that the function? Instead of just having something that returns this, why don't we change this? We'll say entity get Illumina scene get entity children, right? And then just change this to return Illumina entity array. And then here we can actually do U16 pointer out count. That I think makes a lot more sense, actually, because then we can actually use this as the utility function to get other things. But this is also probably going to be what we want a lot of the time too. So this will return to us a list of handles that is the direct array of handles. I wonder if we should do the only risk with that is if the user overwrites that list, right? Which, I mean, there's only so much we could do about that. if they try hard enough, they could do it anyways, I suppose. So, we could return a copy of it. We could return a copy of the array, I guess, instead of the actual array. I'm not going to do that for now, unless for some reason it actually bites me. Because that's just kind of needless complexity, right? So what we'll do is we'll say out count is equal to that, and then we'll return children, right? And if we don't have a children array, we will return 0, but we'll also set the out count to 0 as well. And then up here, we'll also do the same thing in the case of height map terrains, right? A couple other things we're going to want to double check. We should probably I guess we'll just take this, right? There's a couple other conditions we're going to want to check because this is going to become user code. So we want to go ahead and check, first of all, if we don't have a scene, or we don't have out count, or if entity is equal to Illumina entity invalid, right? If any of those are true, we're going to just return, we're just going to say we don't have anything, right? So safeguard a little bit there. And then other than that, I think we should be good on this. So let's head over to the header file. And we can actually just put this here. And then as far as these two functions, this pretty much replaces that, right? Oops. There. Okay. So that pretty much replaces that, which means that this function down here, get child at, we don't need anymore. And that becomes pretty straightforward, I think. Okay. Smudge, good to see you. How are you? Welcome. Dingus Dev, good to see you. Thank you for the lurk. I appreciate it. Okay, so let's see. What else is broken? Entity get transform. I think that's fine. Although we could arguably make sure that the transform is up to date on this before we actually return it. We'll have to see about that. So remove entity. Okay, so this is going to be something that we definitely have to address. So whenever we remove an entity, and this is going to be down here in the general stuff, we need to do two things. So we need to remove it as a child from the parent if there is one, and reparent the children of this node to that parent, right? So I guess we really do need a way to sort of look up what the parent is. I mean, that's not really hard to add. Let's just add it. You know what? It'll make our lives a little bit easier in some scenarios. We'll just do parent. All right. And then when we do, let's see, when we do entity, what is the thing I'm trying to think of? Thank you for the follow. Appreciate that. Doing okay. Had some car trouble on the way home from work, but luckily I got it fixed quick. Ugh, been there and done that. Yeah, I've had everything happen over the years, from flat tires and overheating to my transmission completely pooping itself in one of my old cars on my way home. as I was driving home sick because I had a raging migraine. So yeah, I've been there. I feel that pain for sure. Do we want... init-based entity, I think, is actually where we should do this. Let's see. We don't have a parent in here in init-based entity. So I think whenever we're calling this, we should probably just go ahead and also say, let's see, entity. Here's the lookup. Do we actually have... all we have is the base entity, which I think, okay, I think that's fine. So set to have no parent, right? So we'll just do base parent equals Illumina entity invalid, right? So that gets called every single time. And so what we'll do here is remove as a child from the parent if there is one, right? So we'll do Illumina entity parent equals. Do we actually have typed entity base? We do have base parent. Okay. So if parent is not equal to Illumina entity invalid, then we'll go ahead and perform that, right? So we'll just say oops. Where did I wind up? Here we go. So I guess probably the way to do it I could do it here. This might wind up also needing to be something that we split out into a function if we do it too often, but it should be pretty straightforward. So if we have a parent, essentially what we're going to do is let's see, I guess we should probably do and actually we need to get the parent base first, which means we actually need to get the, I don't know if we actually have a quick way to do that. We don't have a quick way to do that. We should write that. Okay, so what we need is a way to get sort of the base data for an entity regardless of its type, right? We just need a pointer to that. So I think probably the way to do that is actually going to be something like this, right? So we'll just actually take this and let's see. This one can probably be a static function, I think. So we'll do this, and then we'll do static, and then we'll do entity base, or base entity. And we'll do get entity base. And we'll do Illumina entity, and come down here. Right, and instead of the name, right, what we're going to return is the base, right? So we don't actually want the name property, we just want the base. Right, and I guess for terrain, we'll just do we'll spit out the function name, and then we'll say height map terrain not yet implemented. Right. And we'll do return 0. Yeah, okay. So for all of these, we just need to return the address of those things. Oh, we don't have the scene. Oops. So we need that. So we need the Illumina scene. Right, and base entities obviously don't have a base. Okay, so if we take this, go up top, and let's see, after all of our type defs, we put this one, I guess, at the bottom, because that's where it physically exists in the file. Now we can get a pointer to the base entity type without having to do all that switching all over the place. So things like this now become a lot easier, right? So base entity base equals get entity base, right? We pass it the scene. And then the dereferenced entity. And then obviously, if we have a base, and that base has children, then we can do, you know, a U16 count. And here we can just say darray length base children, right? And then do a for loop through that. U16i equals 0, I is less than count, plus I. And then all we have to do is say where, if the base children sub I equals dereferenced entity, then we have our match, right? So we can do darray remove, or darray, what is it? I thought it was remove at, pop at maybe? Yeah, darray pop at. Okay. Okay, so we'll do darray pop at, right? We already have the array, which is going to be base children, and then index is just going to be I, and then the destination would, I guess, just be you know, Illumina entity popped handle, and we'll just do the address of popped handle. Okay. Does this return a result? Just returns the array block. Let me look at something real quick, because that I don't believe. Yeah, we don't actually shrink the array, so there's no need to reset it. I guess we're just doing that for function chaining if we wanted to do that. All right. So we remove that. Remove it from parent. All right. And then let's see. If we found it and we've gone ahead and popped it out, then we're also going to want to go ahead and insert the current entities, children,
You dingus.
and set their parent to this parent. Right. Thank you for the follow. Appreciate that. Let me see. Let me catch up on some chat here. It's kind of in the zone as it goes. Let's see. Luckily, it was just a simple wheel speed sensor. Oh, okay. That's not too bad then. Oh, the whole car craps the bed just from that? That's crazy. Standard Pointer, hello. How are you doing? Hope you're doing well. Potham, good to see you. First time chatter, Severine? I'm probably butchering that. Sorry about that. Welcome, though. Looks like my type of C code. Awesome. Well, welcome. Pronounce my name any way you want. I appreciate that. Yeah, sometimes I butcher it. I try my best, but I don't always get it. You look like Voss. Vauce. I don't know who that is, and I'm terrified to Google it, quite frankly. I don't know if that's a good thing or a bad thing. You'll have to tell me. All right. So I think the best thing that we're going to do here, or the best way that we're going to handle this, is we actually have... Do we already have the base entity looked up? I think we do. Yes, we do. Okay. Oh, this, you know what? That's bad because it's already called base up here. This should be... Wait a minute. So we get the base of this one. Base children. This should be for the parent, not this one. This should be... Right. And then this should be... parent base. Yeah, there we go. Okay, that's why I was confused. Bad naming there. Okay. We search the parent's base entity type. We look through those children. We say, okay, we found one. We go ahead and remove the current entity that we're removing from that parent's list. Then what we go ahead and we do is we say, okay, now for the current entity that we're dealing with, look at all of its children and reassign its children to, or reparent its children to be a part of the part of this guy, right? Art Burklaus, raiding with a party of 15. Thank you so much for the raid. Good to see you, Art. How are you? Welcome, raiders. Yeah, so what did you get up to? First off, what did you get up to on stream? What were you working on? For those of you who don't know who Art is, he is another streamer here on Twitch, who is also a fan of writing his own tech. So he's making a pretty cool, like, retro FPS looking game called the Warlock's Gauntlet. And he's writing all the tech from scratch himself, including the renderer and all that stuff. So he's got a bunch of really cool stuff over there. He also writes a lot of his own utilities to build that. So definitely go check out his channel. Definitely worth a follow. If I hadn't been streaming tonight, I'd probably be watching his stream, quite honestly. What makes it worthy of the multiple A's and N's in game engine? I don't know. I don't know. All right, so for the benefit of the raiders, I'll just talk for a quick second about what we're doing. So we are in the process of making a game via making a game engine first, right? So we're making a game engine that we're building a game on top of, that we're then going to use to ship a game, at least on Steam to start with. So the game engine is called the Kohi game engine, and we've documented the entire process on video. So it started off as like a YouTube tutorial series, but we kind of outgrew that format as the engine kind of grew in size. And it's kind of large now. So the engine itself is written in C, and using Vulkan as its initial rendering backend with plans for Direct 3D and Metal in the future. So we do live stream now. We don't do the tutorial videos anymore. We kind of grew out of that. But we do simulcast to YouTube and Twitch. As far as the engine itself goes, the engine is completely free and open source. So it is available on GitHub. I'll drop the link here to this website that you're looking at here. This is sort of the main hub for the project. And if you check out the GitHub, all of the source code for the engine is here. It is Apache 2.0 license, which means that whether you want to use it for something commercial or personal, you can. It doesn't matter. All that I ask is that if you use it, you say you used it. That's literally it. This is designed to be an educational resource, so I believe that stuff should be free. And so this engine content will never be paywalled in any way, shape, or form. There will never be any sort of licensing or royalty fees associated with the engine whatsoever. So there is that. I can't actually run it at the moment because we're actually reworking something, which I'll get into in just a second. But here's a couple of older screenshots of sort of our testbed project, where we've got a basic PBR pipeline in place and cascading shadow maps, a small UI system, the ability to render UTF-8 text, that kind of thing, and a small sort of test bunch of components that allow us to edit objects within the world. So that is that. As far as the rest of this goes, the engine itself is cross-platform, so it works on Windows, Linux, and Mac OS. And yeah, this just has a couple of links here to like the YouTube, the Twitch channels, Discord, the GitHub here, as well as Patreon. I don't have any sort of sponsors or anything like that, aside from you guys. So that's all there is. Essentially what we're doing now is we are in the process of battening down the hatches on a lot of things, and getting the engine ready to, I guess the engine's already ready to develop a game on. We've actually started writing the game code. The game is called Shadows of Illumina, so all the references to Illumina that you see in the source is the actual game code, versus anything that you see Kohi is associated with the engine. Thank you for the follow. Appreciate that. So we are in the middle of sort of scaffolding the game project, and as we go, since this is a brand new engine, we just kind of have to eliminate pain points along the way. But yeah, that's kind of the quick 2-minute version of what we're doing. Let me just catch up on chat. So the game engine is purpose-built or general purpose. So both, kind of. And I say that with an asterisk. So I'm only building in the engine what I actually need to make this game, right? So the engine itself knows nothing about game types or any of that stuff. And to that point, actually, we do have a scene and like a render graph that we're actually phasing out of the core engine due to that philosophy, right? So the way that the engine is designed is we want the application to know and drive the way that the data is handled, rendered, organized in memory, etc. And so to that point, we had sort of a generic scene. We had sort of a generic renderer. And we're dispensing with that, right? Because generic stuff tends to be heavy. It tends to add a lot of code overhead and a lot of performance overhead that we just don't need, right? Oh, wow. Second raid. Apex Pixelated. Thank you so much for the raid with 5 viewers. I appreciate that. We actually just got raided a minute ago. So I'm going to, I guess, double back and give you guys a quick intro in just a second. But yeah, long story short, we're basically making things that are standard or are known by the game. We're moving those generic components out of the engine and putting them in the game code because it makes sense that something like the scene and something like the application renderer know, how the data is organized, what order it needs to be rendered in, all that kind of stuff. Making generic stuff just doesn't really fit the theme of what we're doing here. So it's kind of a long-winded answer, I know, but I hope that makes sense. Appreciate the follows, by the way. Gradually replacing an old system for world data storage that was in a 3D array to one that is in a 2D array. It's going well, but the old system was there almost from the start 4 years ago and is deeply embedded. I feel that. I'm kind of doing something similar right now. A lot of pulling the weeds out by the roots, seeing what they were attached to and what was also relying on them. Yep, totally get that. Ultimately, making the engine much easier to work with, though, definitely seems worth the trouble. That's always worth it, right? 100%. So yeah, that's kind of what we're doing here too. All right. Yeah, so again, thank you and welcome, Raiders. So Apex, what did you get up to on stream? Kenny Plays, welcome, and thank you for the follow. I appreciate that. Double raid time, yeah, exactly. I have to drop off and take care of my dogs. Yeah, go for it. Totally get that. Thank you again for the raid. I appreciate it. Okay, so I'll just back up real quick and give another quick intro. Let me see. Let me find the window here. So all the way over here. All right. So what we are making is called the Kohi game engine. It's a game engine written from scratch using C as the programming language and Vulkan as the initial rendering backend with support for Direct3D and Metal planned for the future. It is cross-platform. It's available for Windows, Linux, and Mac OS desktop platforms. We do have others planned in the near future, but that's what we support for now. It is free and open source, so it is available. I already had that open. It's available here on GitHub. Again, I'll drop the link in chat. And so it is Apache 2.0 licensed, which means anything having to do with the engine itself is usable for either personal or commercial projects. It does not matter. All that I ask is that if you use it, you say you used it. Like I said, it is open source and free. So that means that there will never be any sort of software licensing fees or royalties of any kind associated with this engine. That is because we started this as an educational exercise. It's kind of the resource that I wish I had when I was learning how to do this stuff. So we walk through the whole process of designing and creating the game engine from file new, from absolutely nothing, creating the GitHub repo and everything, all the way up to where we are now, and eventually releasing a game on Steam with it. And so, this includes everything. It started off as a tutorial series, but we kind of got away from that. And it's not like a curated, scripted thing anymore, right? It's we show all of the pros and cons, the banging the head against the desk about, debugging issues and design decisions and what works, what doesn't work. And so being an educational resource, we try a lot of things. We experiment with a lot of things on here. We try things that work. Sometimes things work, sometimes things don't work. And we do a deep dive into those things as to why. And then, we go ahead and explore that, right? Because I think, just having something that's fully scripted and curated is not always necessarily that valuable when it comes to learning. I feel like it's a lot more valuable for you guys to be able to hear my thought process behind the decisions I'm making as we go along the way. So I hope that makes sense. Let's see. How long have you been working on it? I imagine you've got quite a lot of time invested. Yes, you would be correct. So initially, things weren't moving quite as fast. And not that they're moving all that fast now, but I do work on this less than part-time hours every week. So I would say a maximum of probably 10, 15 hours a week, max. So that being said, I've been working on this for about 4.5 calendar years, but at way less than full-time hours, right? So if I were doing this, full-time hours, we're realistically looking at probably just a little under a year of actual development time. I think it's a pretty good rate of progress. Yeah, exactly. I would agree with that. Obviously I do have a full-time job, so I can't work on this full-time. I wish I could, believe me, but that's kind of where we're at now. We're kind of starting to dip our toes into some of the game code. And then as we do that, we're kind of finding pain points along the way that we're, resolving. Which means it's fairly far along. Yeah. I wonder if I haven't tried to build this yet, I might actually be able to run it. But who knows what's broken. A lot of stuff's broken. Okay, yeah, like my transform system is completely busted at the moment. So this is not a very good example of what we have, right? Because this is a very stripped down example from what you see in the screenshots. The screenshots I showed you earlier are essentially our testbed application, which is where I just jam a whole bunch of stuff in there as I'm developing features for the engine. What we're looking at here is actually the beginnings of our scaffolding for our actual game that we're going to be working on. So this has basically no assets in it yet, just a couple of test things here and there. And I literally just rewrote the entire scene system and the entire game renderer completely from scratch. And we actually just got that stuff running last stream. So it's not the best visual example, unfortunately. But we do have, some of the stuff working. But yeah. And we have some issues, as you can see down there. But we're working through them. So what we're doing now is we had this sort of separate hierarchy graph that we used to manage entities and their hierarchy. And the reason that we had that is because on our old system, which was very open and generic and all the things, we could actually have nodes that had hierarchy but did not necessarily have transforms all the way down that hierarchy. Because the concept is that you don't necessarily need a transform on every single node. They were called nodes at the time. Now we're dealing with entities, right? And so we had like a skybox and what was the other one that we had? With skybox and a there's another one I can't think of now. Might have been maybe the directional light. And we didn't technically need transforms for either one of those things. Arguably the directional light probably. But so the idea is that you could just use a node, right, to just group things together, but that node didn't necessarily have a transform. We're dispensing with that. It was a cool idea. It worked. But we're opting for simplicity here. And in this whole simplicity path that we've been on for the last couple months, I think, I actually have done more code elimination than adding. So far we're almost at a 3-to-1 elimination versus new code rate, which is good. Let's see. Do you have any automated unit tests? I have some, not a whole lot, not anywhere near as many as I should probably have. Are you mainly having to retest everything with changes? Yeah, so being that we completely just ripped the entire thing apart, I don't really have tests for any of this new stuff yet. But I do have a testing framework that we also wrote from scratch that I'm going to use to unit test all this stuff. So 3D Code Warrior, hello, how's it going? All right. You, Pseudo Tokyo, should collab build together. Do you mean Tokyo Spliff? Is that what you mean? He's a Giga Chat over on the YouTube side for sure. New here. How long have you been doing this project? It's been about 4.5 years, roughly. Okay. So let's see. So what we're doing is we're getting rid of that entire hierarchy graph system because we had this whole separate graph that we used for this, right? Which obviously involves the overhead of storing all of that extra data in a generic way. We're doing away with that. So basically what we're doing is on our base entity type, so all entities essentially have this base type, right? So this is just a structure. And then we have a single level of what I'll loosely call inheritance, right? And it's not the type of inheritance you would think about when you talk about OOP, because we don't have any functions associated with these things or any of that kind of crap, right? All we have is, for these specialized entity types, we have one level of inheritance, which basically means the first member of each struct is that base entity. So each one of these specialized entity types contains that base entity within it. So the nice part about that is because it's the first member, you can also take these, any of these, and simply cast them to a base entity if you want, and you have the type there. Within that base entity, you also have the Illumina entity type, right? Which is just an enumeration that contains all of the actual types, right? And so the nice part about that is that means you could take a base entity and also cast it to the type to actually figure out what type of entity it is. And you could also do, entity.base.type as well. That's another way to get to it. Either way works just fine. But if you wanted to, you could basically take a static mesh entity, if you didn't know what it was a void pointer or something, and you could just cast it straight to an entity type and get that information. So there was a very specific reason why we did that, right? And then within that base, we have a dynamic array of children. So that's how we're going to build our hierarchy going forward. And these Illumina entities are not actually base entities, so it's not this actual structure. It is a lookup, right? So it's a unsigned 64-bit integer, right? That contains a few things. So we have the entity type in there and the entity type index, right? So each one of these entities has a type, an array type within the actual scene itself, right? So we have an array for each one of these things, typeless entities, which are just base entities. Those are used for like containers. And then we have static meshes here. We have point lights, spawn points, volumes, hit shapes, water planes, audio emitters, and we'll have more. So that type index is an index into that individual array. So the beauty of this is that when you actually use a Illumina entity, it gives you a whole bunch of information all packed into a single U64. It allows you to very quickly look up entities, right? So that's just kind of the way that we do that, right? Okay, so what we've done here is we're saying we are in the process of removing an entity from the scene. So the first thing we do is we get its parent, if it has a parent, right? And we remove it from that parent, right? And then we should probably actually, now that I'm thinking about this, I should probably refactor this a little bit because we're going to need to do a couple of things here. So let's go ahead and let's see. If we have a parent, then we're going to go ahead and remove the entity that's being removed from the scene from that parent's children list, right? Which makes sense. We pop that out here. Whether or not we have actually done that, in fact, we could actually just break here, right? We can break that loop there. And that's going to put us here. So once we've done that, then we'll need to handle this. There's two ways we could do this. We'll need to assign, you know what, in fact, okay. If we previously had a parent, let's just do it the dumb way first, and then we'll see about making it a little bit nicer. Okay, so if we had a parent, right? This node has been removed from the parent. What we also need to do is we need to go ahead and get the children of this particular node and reassign those to the parent, right? The old parent. And so what we can do here is we could do U16, and we'll do child count. We're going to say darray length. And instead of parent-based children, we're going to do base children, right? So that's of this particular entity that we're removing. However, it's possible that this entity does not actually have any children, right? So we need to first say, do we have any children? If we do, let's get the darray length from that. If we don't, let's say 0, right? And then we can do a for loop through that. So I think I can just do another boomer loop here. So we'll do U16, I equals 0, I is less than child count plus I, right? And what we can do is there will be 2 operations that we'll have to do on this. So we'll just have to do base entity child equals get entity base, and we'll pass the scene, and then for the entity itself, it's going to be base children sub I, right? And on that child, we are going to set the parent handle to parent, right? And then we'll set actually, that's all we need to do for each one of those. For each child, that's all we need to do the child. And then let me think about this for a second. And then we'll need to do darray push, darray push. I don't know why my code completion isn't showing up for that. It freaks out sometimes over macros. So we want to do the parent base children. So into that children array, we need to push a handle for this child, right? Which is just going to be base children sub I, right? So we reassign its parent, and then we add to parents child list, right? So we do that for each one. Now, the reason I was kind of mulling this over before is because we have 2 scenarios where we can do this, right? So if we don't have a parent, then we're going to have to do this anyway. So we're going to have to take this, right, and jam this over into an else. And the only difference is going to be is obviously we don't have a parent base, right? So we don't have an array to actually push into for this, which is fine. But the child parent then needs to also be set to Illumina entity invalid, right? Because now it's basically a root element or root node sort of in the scene. I guess I really don't actually need to even separate this out to a separate variable. We could actually just do that, right? And then we'll just do that. Yeah, that feels a little cleaner, right? So we can do parent equals parent. All right. So that should handle everything we need it to handle. Let's see. If this does not have a parent. Now, if this, So if the parent base does not have children, then we're still not going to hit this. So there is another scenario where we're going to have to do this, right? And this is kind of where it gets kind of dumb, right? So we would also have to do this, which is kind of poopy, right? Because if for some reason we don't have a children array, then we still have to do this anyways. It's nice. It's sort of a form of C-type introspection. Yeah, exactly. I don't remember where I picked up this pattern from or thought of it or whatever, but I've used it a few times. Might have actually been the Vulkan API that I stole that from. It works pretty well. Although the Vulkan API doesn't do the inheritance bit with its structures, but that's neither here nor there. This is kind of a mix between the two. All right, so let's see if we can make this less crappy. So I think I could probably just hoist up base entity, right? Parent base, and just set that to 0. Right, we hoist that up. I don't really think we need to check this, right? Because if this isn't Illumina entity invalid for the parent, right? Because the parent is actually yeah, this is the only place where it could actually be. So so we actually don't need to check. Let me clear this highlighting. It's a bit insane. We don't need to check this, right? Because we know if this is true, this is definitely going to be true. So if we have the child array in the parent, then we have to remove this from the parent. That makes sense. And then I think we can actually just deal with this down here at the bottom, outside of all of this, right? I think we can actually get rid of all of that, whoops, and all of that, and then just say down here, let's go ahead and iterate the children, and then if the parent is already invalid ID, right, then that's just going to get set here, which is fine. That we already need to do that, right? And then here we could actually just say if parent base. And that'll keep us from having to do that same block of code a bunch of times. That should get us to where we need to be. All right, so all this hierarchy node stuff, that goes away. So does that. Cool. All right, so that is removing an entity. And now adding an entity. Adding an entity is going to be, let's see, I think all of these actually have parents on them now, so that's good. Okay, so where we are doing this hierarchy node stuff now, and actually hierarchy node index, this actually is something I'm going to have to revert as well. So this base entity, init base entity, takes in the entity index, right? The entity type, and then a hierarchy node index. We don't need this hierarchy node index anymore, right? We don't need that. So we can get rid of that. And when we go to pack in stuff into the entity, we no longer have anything here. So I had switched this to a U64 to actually hold 4 things, but I think I can actually switch it back to a U32 now and save ourselves some memory. But I see base hierarchy node index in here. Is that still... Yeah, we don't need that guy anymore. We can get rid of that. All right, so I'm going to hold off. I'm going to hold off on reworking this unpack logic because right now it's a U64. I can't think of anything that we're going to have to add to that. And in fact, we already had one empty slot anyway. But I might wind up switching that back to a U32, which means I'll have to change the tests for it again, but that's neither here nor there. All right. So add entity. Okay, so this is the base type, right? So we can get rid of hierarchy nodes. We don't need that. And then init base entity. All we need to do is remove that. And then we don't actually need to do this anymore. So this is one of those extra storage things I was talking about with the hierarchy graph. We don't need that anymore. What we do need to do though is after we create the handle, right, which is this Illumina entity here. After we create that, we need to use that to say, well, first off, if, let's see, actually, we could probably just do base entity, parent entity. Thank you for the follow, appreciate that. Parent base, we'll call it. Get entity base, scene, parent, right? And then if we have parent base, then all we have to do here is one of 2 things. So we either need to, oh, I just thought of something else that I'm going to need to fix. Okay. Now I'm actually thinking I should probably make this a generic function. I'm going to put it here for a second. So static return type void's fine. I guess what we'll do is entity add child is what we'll call it. And we'll do base entity. We'll take a pointer to that, right? So that's going to be base. And then we are going to add Illumina entity child. Right? So that's going to be basically this section here. We should probably call this parent, right? And actually, since we have that, you know what? Let's keep this. Let's do Illumina entity parent, right? And then obviously we need scene as well. Illumina scene. Whoops. Illumina scene. Okay. So if we get a parent base, then we're going to go ahead and say if parent base children, right? If that exists, then we'll do darray push, right? And so we'll push into parent base children. And then we'll push child, right? So let's actually, you know what, this, I could simplify this even further. Let's move this down and change this to a not check, right? So if there is no child array in the parent, we need to do darray create, actually parent base children equals darray create. And that's going to be Illumina entity type, right? And to that, then we can push child, right? So it'll create it if it doesn't exist. Otherwise, either way, it'll go ahead and push it. I think that makes sense. So here we can do entity add child scene, and then we can do parent and entity. Automatically just adds it into our hierarchy for us. I could, I suppose, if we passed parent to init base entity, if we did that, I could just do it inside of init base entity and not have to worry about it. Maybe I'll do that. Mahmood over on YouTube. I'm good. How about you? Welcome. Thank you for asking. Let's see. We also are doing all of this in a few different places too, which is kind of rubbish, if I'm quite honest, right? We're doing it here and we're doing it for all of these. It'd be nice if we could just go, you know what? Transform included, because I think we're also repeating that logic, right? Transform included. It'd be nice if we could just, handle all of this in one spot. Because we do all the node specific stuff after that. I think we have another opportunity to clean up some code here, folks. And get rid of some of this repetitive poop that we have in here. So let's see, hierarchy node index. Oh, we don't need this function at all. Let's get rid of its implementation first. And get hierarchy node for entity. We don't need that either. Which is going to eliminate both of those. So that's cool. So we don't need we don't need either one of these actually. Perfect. Even better. So really it's just adding the child in here once we do init base entity, which I think is probably going to be the way to do it. So let's see. Init base entity. The parameter order of this is a little weird, I'm not going to lie. But I don't feel like changing that now. All right, so let's add to the end of that. We'll go ahead and add all the way to the end. We'll do Illumina entity parent. Right, and we'll do the same there. Okay, and then all we have to do is come down here and do, whoops, parent, right? And then we'll take this, go down here to this function, and right after we do the scene or the name lookup stuff, we'll just add it as a child to the parent if need be, or if it exists. Okay. So that makes sense. That's a lot cleaner. I also want to take this, and let's go in here with this as well, right? So before we actually save off the transform, if we do not pass a transform during creation, we'll go ahead and create one. So that definitely is going to get rid of some complexity there. I really would like to eventually set up a macro for this kind of stuff, but I think I'm okay not doing that for now. Okay. So what that means is for all of these other types, we essentially get rid of all of that. go here to the end, replace hierarchy node index with parent, and then delete that stuff. Yep. Okay, cool. So more code deletion. Awesome. Always love deleting code. I know that sounds a little bit weird coming from somebody writing code, but those of you in the know exactly what I mean. Simplicity is much better most of the time. So let's see, we get rid of this, boop, and change this to parent, and then get rid of this poop. And next, so we get rid of this poop. You can replace it with parent. And get rid of that. I should have thought of this before, but you know, when you're banging out code sometimes copy pasta is just faster. And that's the way of things, right? The key is to occasionally go back and just recheck your stuff. I plan on doing a full pass on this entire set of changes before we actually merge this into main. Okay, so we got one last one here. This is going to be parents. Cool. Look at all that stuff we deleted. Much, much better. Okay, now Illumina entity pack. Get spawn points. So we don't actually need this anymore. So all we're doing is basically just packing or creating new handles from that array. Okay. Might want to find a better way to do that, but for now I'm okay with it. Okay. So let's have a look. I guess let's head over to let's see, is there anything in here having to do with hierarchy nodes? I don't think so. I think we got rid of everything. Okay. So let's head over to the header file and see what we have here. So we have scene destroy. I'm not really too worried about that yet. I'm not going to actually set that up until we're done with the rest of the implementation. Let's see. So state gets, and then you get my name. Pretty sure. Actually, I think we can simplify this one. Get entity name. This is the one I was thinking to simplify. All right. So let's actually go to base entity equals get entity base, right? And we'll just do scene entity. And then here, all we actually have to do is if base, we return base name. Otherwise, we return invalid kname, right? We get rid of all of this. We don't actually need these things either. So that's another place we could simplify. Okay, so get entity children. This is actually another one. We could actually basically do the same thing that we did here. So we'll do this. And let's see, children is equal to 0. Let's put this here. So if base, then we do we do dereference out count. We'll set the value pointed to by out count to cast u16 darray length base children, right? And then we'll return base children. If we don't have that, then we are still going to use this case down here, which is basically just going to be that. Much, much, much simpler. And let's actually utilize this again. Same thing for transform, right? So we can actually, again, simplify our lives a little bit here. So we don't actually need that. We're just going to return base.
You dingus.
Dingus is right. Thank you for the follow. Appreciate that. Welcome. So we'll keep all of this except, or we'll delete all of that rather, except for there. Right? Cool. Well, that's a heck of a lot easier. Okay. I don't think I can do that with this because this has like specific entity type handling in it. So that's not going to be quite as easy. I don't think we can really do much of anything with that. Entity add child. You know, this could probably actually be... I don't know if I want to expose that. Because then we would also have to check to see if parent already contained child. If child was parented to something else besides parent, then we have to unparent it and remove this child as a child of those other things. I don't know if I want to go down that route, right? One thing I do... Well, wait a minute. Let's see. Oh, there is something we forgot to do here. We did not set the parent on each of these. Wait, or did we not? Yeah, we did not set base entity child equals get entity base scene child. And actually we don't even need to do this because I'm just going to be setting the parent. We'll do parent equals parent. Yep, that makes sense. Okay. Okay, so we've already done all of these adds, so these should all be good. I think we might be done with getting the hierarchy stuff added across the board. Now, when it comes to getting transforms, that's where it becomes a little bit tricky, right? So, there's two ways that we can handle this. There's the dumb way, and then there's the trying not to be dumb way. I think I'm going to go with the dumb way first. So I'll explain to you what the difference between those two things is. So there's the dumb way is essentially saying anytime we get the transform for a particular entity, we do a check and we say, hey, work your way up the hierarchy tree and let's actually calculate what our transform should be every single time we retrieve that thing. And then, you know, we just recalculate it every single frame all the way up. And that's just kind of the way that we do it, right? That's one way to handle it. And that's the simplest, right? Because you don't have a whole bunch of, you don't have to worry about caching. You don't have to worry about any of that stuff. So we might actually go the other way now that I'm thinking about it, because we do have a transform system where we can set a world transform. And we can use that to cache the world transform, which is going to be what we're going to want to get the model matrix for everything that we're going to render. So the transform system does have the concept of local and and global transforms. So let's see. I think it's literally just calculate local. So we calculate the local transform. Do we have something to calculate the world transform? I don't think we do. We have a way to set it, which is fine. I guess we could handle that in the scene. This is really nothing more than a cache, right? So in the scene update, I guess, is probably going to be, we need a reasonable way to iterate through the scene, right? Ideally, you would probably go top down. So you'd start at like all your root nodes, and you would cascade through all of the children and the children of those children and so forth. But we don't have that view. We could make that view. But I wonder if that is I wonder if that's a good thing to do. Because any entity that's at the root level is going to know what its children are, right? So really what we need is a list of root entities. We don't necessarily have to manage that whole tree. We really just care about the entities that are not parented to anything or root. So I guess what we could do, is when we initialize a base entity with a invalid transform. No, not with an invalid transform. Without a parent. Wait a minute. Why is this? That's wrong. That should be parent. Let me put these together, actually. And actually, I think we don't even have to do this. Oh, that's why that was down there. Base parent. Doesn't this do... Yeah, that already sets the parent. So we don't actually need to even do this, because that's handled for us down here. Okay. So whenever we add a child, right, which is going to be called on every single entity that we initialize. So whenever this gets called, and Illumina entity parent here is an invalid entity, then we could just add it to that list. Right, so on the scene, if we have, let's see, where could we put this? I guess we could put it, let's put it here. We'll say Illumina entity, root entities, right? And this is going to be D-array of parentless entities, right? So let's see. If we don't have a parent base, which would result in us calling this we didn't actually check something here. I'm glad I went into this. So if entity equals Illumina entity invalid, we want to return 0, right? Because there's nothing, we shouldn't even bother with any of these lookups if that's true. So now we can actually use this. Okay, so if we don't have a parent base, right, then we need to add to the scenes root list. So I guess we should probably go to, what is it, scene create. We should probably go in here, and before any of this other stuff, do scene root entities equals darray create, and this is going to be Illumina entity type, right? Just so that always exists, and we don't have to check that here. So we'll do darray push, and that's going to be to scene root entities, and we are going to push child. And that'll make sure that that's done there. Now in remove entity, when we're doing all this other stuff, when we remove an entity, we're unloading it and like destroying the handle and all that good stuff. We also need to make sure to remove it from the root if that is the case, right? So let's see. Actually, we could just do that here. So if parent is not equal to Illumina entity ID invalid, so yeah, else, right? So if it has no parent, it's a root, remove from that list, right? So unfortunately, we don't have a way to remove by value. I could add that, I suppose, but I feel like that's something the user code should do because it's kind of an exception thing. So we'll do u16 length equals darray length scene root entities, for u16 I equals 0, I is less than length plus I. And then we'll do if scene root entities sub I is equal to, I think it was just entity, yeah. Then we'll do darray pop at, again, scene root entities, and then index is going to be I, and then destination, I think we can actually pass 0 here if we don't care. Pointer to hold the pop to value optional. Okay, yeah, so we don't actually care about that, so we can actually just pop that out of there. Root entities equals entity. What is Illumina entity? What is the, oh, right, we need to dereference it in this function. Okay. Let's see. Because we set it to invalid afterwards, that's why. Okay. So yeah. Now it's removed from the root. Give me 1 second. Okay. Let me see. Let me catch up on messages here. How can I split an unindexed mesh into groups of 8 joints each or indexed, but takes too many splits? But I'm not sure what you mean. When you say an unindexed mesh into groups of 8 joints, are you talking like an animated mesh, like a skin mesh? let's see. How long could it take for a beginner in programming to learn Vulkan programming? Ooh boy. So before you learn Vulkan or any sort of graphics programming, anything anywhere near graphics programming, you need to have a good command of the language that you're going to be using to write it first, which is typically C or C++. And you need to be pretty good with that language, right? Because you don't want to be tripping over that while you're trying to learn Vulkan at the same time. So my recommendation there is, if you're new to programming, I usually suggest C first because it's a far simpler language, and then step to C++ if you want. But don't do the opposite, because C++ is a very complicated language. And if you understand C first, C++ will make a whole lot more sense when you get to it. That being said, though, before you even jump into any sort of graphics programming, the prerequisites are you have to know and be good with, either C or C++, generally speaking, unless you're going to use WebGL or something like that. But if you're talking Vulkan specifically, that's C++ land, right? Generally speaking, or C. So you need to be good with that. You also need to be good with linear algebra, so vector math, things like that. So you'll need to read up on that, and then at that point you can start jumping into graphics programming. But I usually say, if you're learning graphics programming and you've never done it before, don't start with Vulkan because it's going to overwhelm you, right? Start with OpenGL first. Yes, it's deprecated, but it still works. It's not going anywhere anytime soon. Deprecated just means that it's not receiving updates, but it's not obsolete, right? There's a difference. So at that point, definitely learn OpenGL, use OpenGL to get good with the graphics programming concepts. And then once you're at that point, then move on to Vulkan, right? Once you've written a couple renderers with OpenGL, then you move on to Vulkan. And that's a very high level explanation, but that's kind of where you have to start, right? All right, I'm going to have to skip, I think, some of these messages just to kind of keep going. But hey, Adam, how's it going? Good to see you. I'm well, thank you for asking. No joke, I watched for 1 year of videos of Vulkan developers before I even attempted. Yeah, so the funny thing about that is, so let me show you something really quickly, and then we'll move on. Let me grab the right window here. Actually, let me pull this up off screen just to make sure. I don't want that one. Make sure I get the right one here. Okay. So this is the Vulkan spec. If you're going to learn Vulkan, this is your guide to the whole thing, right? You can look at tutorials and stuff to kind of get an idea on some of it. But if you're looking to get used to it, like, or really actually jump in and use it, you're going to need to read this document. Now, notice how long that document took to load, right? It took a minute, right? This document doesn't contain any pictures, any fancy CSS. That is how much text is in this document, right? I'm scrolling continuously and just watch this scroll bar over here. It's a big boy, right? And see, it can't even render it all quickly enough, right? So my point is, you need to go through this document. It's a lot. There's no way around it. You can only get through it, right? And so what I usually tell people when they get to the point when they're learning Vulkan, read this thing top to almost all the way to the bottom, right? At least to, let's see. There's some of this stuff that you can skip, like density map operators and tensor operations. Queries you can probably skip, right? But probably the first 16 sections at least, right? And there's going to be some other stuff down here that you're going to need as well. Rasterization is another big one, right? I would say just read it top to bottom, frankly. Read the spec, write a renderer, throw that renderer out, read the spec again, write another renderer, throw that out, rinse and repeat, right? That's the only way you're going to get good at it. AI still can't one-shot Vulkan? Nope, it cannot. let's see. Yeah, the other thing is if you are new to programming, absolutely do not use AI. Do not use AI to teach you things with programming or to use code from AI or any of that stuff. Do not do it. Do not outsource critical thinking and problem solving to AI. It is absolutely going to hamstring your development. 100%. Yeah, so I hope that helps, at least. All right. I was using Raylib, but Inscription freaked out when I tried to do instance rendering. Oh, I bet. Yeah, there's issues with that one. How's it going, by the way, LSR? AI can be blatantly wrong and think it's correct, by the way. As I discovered the other day when I was trying to use ChatGPT to help me debug an issue. Yeah. I mean, that's the danger with it, right? Have I ever tinkered with Inscription? Not anytime recently. I messed with it, God, like 7 years ago or so, I think, if it's been that long. It's been a while. It's pretty neat, though. But yeah, I've not done anything with it in a long time. Orshi, good to see you as well. Psycode, how's it going? Curious, are the matrices stored as 4x4 or 3x4? I'm doing 4x4. I can always tweak it later because of the way that I've abstracted it from the rest of things. I could always tweak it later if I need to. I could change to 3x4 just to save some space, but at the moment it's not really an issue. All right. So are we done with this? I think. Oh, right. We needed a list of root entities so that we could actually go through and create all of the world transforms of everything all the way down. So the way that we do this is we do update in our scene update, where we had this to do in here, update transforms, etc. Just above our submesh wait on loading queue and all that stuff. We are going to do our transform updates here. So we'll do, let's see, U16 length, or I'll just say root count equals the array length, and we will do scene root entities, right? And then we'll loop through each one of these. Good old boomer loop. 16 I equals 0, I is less than root count, and then plus I, right? Now, we're going to have to recurse this, right? That's the only way that makes sense to me at the moment. So we're going to have a static function here. We don't need a return type of any type, I don't think. But what we need to do is we basically need to go through and say, I guess calculates, I guess we could do recalculate, transforms, I guess. So we're going to want to do that on, let's see, I guess we could just use the base entity pointer instead of having to look up every single time, right? And we're probably going to need, we are going to need the scene still. So Illumina scene. You dingus. Let's see. Thank you for the follow. I appreciate that. Very much appreciated. I've made enough money fixing bad AI code, put me off from ever using it. Yeah, Apotham, exactly. Yep. can be useful for rubber ducking or rubber ducking. Rubber ducking. I like that. Trying to debug, but only when you already have an understanding of what you're doing, and only if it's not just blatantly wrong. Yeah, that's the risk, right? It hallucinates a lot. Yeah, so I would definitely not trust it. You know, like, okay, something as straightforward as math, you could probably get away with asking it questions, right? You know, how do I generate a projection matrix that's left-handed, right? You could probably ask it that and get a reasonable response, but yeah, I still wouldn't even use it for that. There's so many resources out there that you can ask, or that you can look up, you know? All right. So what we'll do is we'll just say recalculate transforms. And we'll do scene and then, whoops, keep hitting the wrong key. Escape, dang it. All right. And then the entity is going to be, we're going to have to look that up actually. Get entity base, scene, and then Illumina entity is going to be the scene root entities sub I. Right, so we can do that. And then in here, just to be safe, we'll say if entity, right? So at this point, we'll need to go ahead and take we need to calculate the world transform for this entity. So for that, we are going to need the actual base entity, or the parent entity rather. So we're going to say base entity parent. I guess we could just say parent, right? Let's do parent and child, right? Just make that a little bit more clear. So for this first level, it's going to be a null, right? And then the address of scene root entities. Oops. I'm editing the wrong thingy here. We want a 0 here, right? So 0 for the parent of a root node, which makes sense. And then we can actually just come in here and right in here create a similar section to recurse, right? So we're just going to do count this time, and we'll do parents. Wait. Yeah, we'll do its child. Children. Right. And so here we'll just do that, and then we'll do calculate transforms will be the parent will be child this time. And then here it'll be children sub I, right? And so that's how that recursion will work there. This needs to be, child needs to exist, right? And then if, we'll say if parent, then what we'll do is we'll say K transform. Should we do, does this automatically, this does automatically recalculate. Okay. Does this, does not re-automatic. Okay. So we'll do local get, right? So we'll recalculate the parent. Oh, but I don't have the, yes I do. So parents transform, right? So we'll do map for parent matrix, right? And actually, let me think about this for a second. So this is actually going to be the local. We want to get the world from the parent, not the local. That should have already been calculated by this point, right? Okay, so we want to get the parent's world matrix, and then we want to get the child's local matrix, right? So we'll do mat for child local, and k transform local get child transform, right? And then we'll do a mat for mul. We'll take parent, and multiply that against child local. This should be parent mat. And we have the new child, mat for child world is equal to that. And then we can do k transform world set. And we'll do child transform, and we'll do child world, right? And so that's that. Now, if we don't have the parents, essentially we're going to need to do something a little bit different. So I'm actually going to hoist this up. This guy. Let's paste that there. And then do child world, right? And we'll move this down. And in here, we'll do child world equals. Let's actually hoist this line up too, because that always needs to run as well. So here we could just do child local and then set it once, right? So if we don't have a parent, we're going to use the child's local matrix as the world matrix, right? Otherwise, we're going to get the parent matrix, multiply the child matrix by the parent matrix, and then we'll have what we need there. And then when we go to get the world matrix for all of these things, we should be getting what we need. So world get, let's see. So that's audio emitter. And then get render data. We are pulling that. So I think Kringer's floss. We might be getting close here. Let's see. D-array. What? Oh, I must have accidentally typed a 5 in there somehow. Okay. All right, Illuminacine 480. Oh, yeah, we definitely don't need that anymore. Cool. Let me also check one more thing. Hierarchy graph should be able to go bye-bye as well. We don't need that. Okay. Let's run this and see where we land. Segfault. Sweet. Recalculate transforms. Ah, right. I didn't take that into account if we don't have any children. What a dingus. Okay. Simple thing to fix. So we'll just do, I don't know why I didn't do this, children. If we have that, we use the D-array length. Otherwise, we'll just use 0. And that'll get us around that. Okay. All right, so we now see our transforms are working. Yes, I realize there's still an artifact here in the water. I do realize that. But we can see that our transform hierarchy is actually working because this this object here, this particular cube, is the child of another transform that we're actually manipulating and moving around the world, right? So we know that works. However, there's a couple things I'm noticing. So it does not look like the initial transform is being taken into account when we parse out the scene. And I think I know why that is. So we need to, I think we're not parsing it, right? Because this tree should not be there. And this guy should actually have a different scale applied to him, right? So let's see if we can go ahead and fix that real quick. Let's see. Wasn't it? Oh, I think it was deserialize. Oh, it was probably actually even deserialize entity, I'm thinking. Yeah, we did have that. Did we just completely ignore transform? No, we didn't. Oh, I bet I know what happened. Yep. I did a mass find and replace. And these are all labeled as K transforms instead of transform, which is what the thing is actually looking for. So that's just a simple K transform global. Don't even need to rebuild for that one. I love when things just work. Looks like it's not 100% correct, but we are at least getting... I wonder if I have my hierarchy backwards, because this looks off to me. But that might also be because I might have actually foobarred this file, because I did convert it to the new format as well. Let's see, that's spawn points player. Here we go. So this is the outer sort of player object that we have. That's just an empty entity. And then we have the sort of wrapper around the mesh, and then we have the static mesh and the hit shape within that. So we elevated it by 2 units on the y-axis. And we have identity rotation. And here's our scale being set. So that looks like it took correctly. I'm thinking it's probably just... maybe the order that I'm... Did I get the order of the matrices backwards? Maybe. I don't think I did, but... K-transform from string. Yeah, I mean, that's not changed in ages, so I don't think it's that. I can't imagine this is backwards, but maybe it is. I don't think it is, but... Oh, it was backwards. Okay. Well, what a dingus. All right. So cool. We have that working, which is awesome. It's great news. All right. Yeah, it's column major. I did have it backwards. Yeah, I thought so, but I always mess that up. Almost always. I'm always getting that wrong. Okay, so this is actually really good progress tonight. I'm super happy with this. This actually means that I can actually knock this off the list. which is really cool. So we just have a couple things left on the list to do. Nothing too crazy, actually. Debug render representation. So that's, bounding boxes and spheres and stuff like that. That's not going to be hard to do. We do need raycast implementation. But that is a fix me in this as well. But so for that, we probably need some sort of bounding volume hierarchy, I'm thinking, in order to quickly iterate that. So we'll see about that. Scene serialization should be pretty straightforward. And then, of course, writing that out to disk. Okay, cool. So I think that's where I'm going to leave it tonight. Really good progress. Happy with that. So what I'm going to do is we are going to raid out. I'll just catch up on a couple messages really quickly. Looking at this area of code makes me feel included. I appreciate that, and welcome, by the way, first-time chatter. Let me see. Let me move this up a little bit so I can actually read a little bit more. Did you see Metal 4 is in beta? Although one thing that's been bothering me, would you say, since Vulkan on macOS is essentially using Metal, therefore does it mean that whatever Vulkan is capable of, Metal is just as good? No. So there's plenty of Vulkan features that aren't really working in Metal. In Molten VK, I should say. They're constantly making it better. But yeah, it's never going to be quite the same, right? And that's one of the reasons why we're going to do a Metal implementation of the renderer with this engine. Is because, I'd rather just, if I'm going to be on that platform, I might as well just write it, Let's see. All right, cool. All right. So yeah, I think it's time to end. So let me find somebody to raid. To be fair, it's partly ClangD's fault because it doesn't detect hierarchical includes, auto include stuff, even if include already does it recursively. Quite dislike it. Yeah, fair enough. Why can't Apple support Vulkan just like everyone else? Yeah, I know, right? And what they did with web GPU is really annoying too, because that supported what you call it? I can't think of the term now. What the heck is the shader language? I can't think of it. My brain is tired. Okay, I'm just gonna raid out. All right. You know what? We are. Let me just find somebody to raid real fast. Okay. Spurvy is what I was thinking of, by the way. Thank you to my wife who reminded me of that. Okay. We are going to raid Spiro. He's a good friend of mine. I'm not sure what he's up to. We'll have to figure it out. Looks like he's having some sort of discussion about AI not improving anything, which is directly relating to one conversation we had during the stream. So I'm going to go ahead and shoot this over to him. And thank you guys so much for joining me. I really appreciate it. And I will see you guys on the next one. See ya.